సార్ రికార్డింగ్ స్టార్ట్ చేశానా?
సార్
రికార్డింగ్ స్టార్ట్ చేశాను సార్ ఇప్పుడే.
ఓకే
బోస్బాబు గారు గుడ్ ఆఫ్టర్నూన్.
హలో శ్రీధర్ సార్.
సార్
పిలిచారా అతన్ని? ప్రొఫెసర్ సార్ని
ఫోన్ చేశాం సార్. మేడం గారు ఫోన్ చేశారు సార్.
వచ్చారా?
వస్తున్నారు సార్, వస్తున్నారు.
ఓకే, అంటే మన వాళ్ళు లైన్లో ఉన్నారు కదా, దానికోసం.
ఎస్ సార్, ఎస్.
శంకవారి చావలి గారా?
బోస్బాబు గారు జస్ట్ నౌ స్టార్టెడ్ రికార్డింగ్.
ఓకే సార్. నాకు కో-హోస్ట్ ఇవ్వండి సార్.
షూర్ సార్.
కో-హోస్ట్ ఇవ్వండి. అన్నా
ఎస్ సార్.
చేసుకుని
Sir, for Bosbabu garu and Ravishankar sir, both have given co-host, sir.
Sir. Finish agar kelipodra. Use effect. Last year. What a glass in there. Chennai on time glass.
Shiv Prasad sir, good afternoon sir. Shiv Prasad sir, good afternoon sir.
Sir, please unmute sir.
Shiv Prasad sir. Sir, please kindly unmute yourself, sir.
I think he is rejoining again, sir.
Yes, sir. Yes, sir. Some
Sir, is
technical
it audible,
problem has
sir?
been arrived. Yes, sir. Yes, sir.
Sir, can you listen me, sir? Shiv Prasad, sir?
Shiv Prasad, sir.
Sir, ఆయనకి ఫోన్ చేయండి సార్ ఒకసారి మీరు.
Okay, sir.
जी
Hello, ji, resolving a technical problem.
Sir, is it audible, sir?
Yes, sir. Yes, sir.
Yes, sir. Sir, Sridhar garu, you can.
Sir. Ravishankar, sir.
Sir.
So, sir is having some technical problem. He is asking only 2
No,
3
no.
minutes time, sir.
No,
He is
sir. He
ready
has
to
already
present
shared
the
the
session.
screen.
Yes, sir. Yes, sir. Yes, sir. That's what he is saying.
Okay.
So now I am ready to present.
Okay, sir. Okay, sir. Okay, sir.
So should I start or wait?
It's a few minutes, sir.
Okay.
So, welcome to second international conference ICDSAI 2023, and the second international conference on data science and artificial intelligence from 24th today and tomorrow, and jointly organized by California State University, USA, LENDI Institute of Engineering and Technology, Vizianagaram, Andhra Pradesh. We are happy to announce the Department of Mathematics and Physics, Geetham School of Science, Geetham deemed to be University, Visakhapatnam, handling the technical session 5 today and tomorrow. So now I welcome the organizing secretary cum chairman, convener, Dr. Bosbabu Sambana, and all the delegates of LENDI Engineering College. And I extend my sincere thanks to our resource person, Professor Shiv Prasad Yadav sir, Department of Mathematics, IIT Roorkee, for accepting our invitation to give a keynote talk in this present international conference. Now, I am happy to introduce the moderator of the keynote session of international conference, Dr. Ravishankar Kumar Chawali Garu. Dr. Ravishankar Kumar completed MSc MPhil in physics from University of Hyderabad with specialization of nonlinear optics in 1994. He has been awarded his PhD degree in physics from Acharya Nagarjuna University in 2010 with specialization in condensing matter physics. He is having around 22 years teaching experience. He contributed to academic activities towards excellence to the Department of Physics, Geetam Timuttibu University. And moving towards his research activities, he published 35 papers as corresponding author in peer-reviewed journals, also reviewer to publishers like Elsewhere, World Scientific Finger, and he has been awarded 3 PhD degrees to their research scholars. And presently, Dr. Ravishankar Kumar working as an associate professor in Department of Physics, Geetam School of Science. Now, I am requesting Dr. Ravishankar Kumar Garu to moderate the keynote session. Thank you, one and all.
Thank you, sir, Sridhar sir, for giving me this opportunity to introduce the speaker of the today's session, Professor Shiv Prasad Yadav sir. Sir, I am glad to introduce the profile of you, sir, and let me convey information to the delegates. Professor Shiv Prasad sir is a professor in mathematics at Indian Institute of Technology, Roorkee, and he has PhD degree in optimal control theory from Applied Mathematics Department, Indian Institute of Technology, Banaras Hindu University. Now, Banaras Hindu University is IIT BHU now. To his credit, he has teaching experience of 34 years, and his current areas include optimal control theory, operational research, data and envelopment analysis, fuzzy optimization, intuitionist fuzzy optimization, and fuzzy reliability studies. So far, he has supervised 16 PhD theses and 7 MPhil theses and 11 MCA theses. In addition to this, he has contributed to 71 MSc students with their thesis work and 4 BTech students for their thesis work. Currently, he has 4 PhD research scholars and 2 MSc students for his dissertation. As on date, he has contributed to academic community, publishing 77 research papers in national and international reputed journals, and also he has 39 research papers in various conferences of repute. And a small token of information that I gained is that Professor Yadav sir is having citations of 2,381 and I-10 index of 52 and H index of 28. Sir, I am happy to introduce you for this today's session. Sir, please. Sir, please.
Okay, just a minute.
Okay, sir. Right.
Thank you, Professor Shankar Ravi, for introducing me. Now I am going to present a little bit theory of data development analysis, and then its application to Mgnrega. As you all know, Mgnrega scheme was passed by our parliament in 2005. Its aim was to work done under Mgnrega. Then I will present data development analysis, a short literature review, some models of data development analysis and related theory, how to validate the data, and finally the conclusion of the talk. Mgnrega Act in 2005 covers employment to the rural as well as urban areas. Aim was for its development, enhancing livelihood securities, improving purchasing power of rural people, empowerment of socially disadvantaged persons, rejuvenation of natural resources, unemployment allowance, durable and productive rural assets. So these were objectives of Mgnrega scheme in 2005. Under this scheme, the work taken was construction of water harvesting structures, renovation of traditional water bodies, watershed management works, afforestation and horticulture in common and forest lands, creating infrastructure for promotion of livestock such as poultry shelter, goat shelter, piggery shelter, cattle shelter, and fodder crops for the cattle. Rural sanitation related works, proving all weather rural road connectivity to unconnected villages, construction of playfields, construction of buildings from Gram Panchayats, women self-help groups, federations, cyclone shelters, Anganwadi centers, etc., construction of food grain storage structures, etc. So these were the works taken up by this scheme. Today, as I said, I will present theory of the data development analysis. It is based on efficiency of a decision-making unit. Initially in 1957, by Farrell, it was defined as output ratio input for a single input, single output case. But Farrell could not implement this work to cover the multiple inputs and multiple outputs, though he tried. But he defined relative efficiency of decision-making units. So it is defined as efficiency of the concerned decision-making unit divided by the maximum efficiency of all decision-making units under consideration. So this relative efficiency lies between 0 and 1, 1 inclusive, but it can't be 0. Data development analysis, after invention of simplex theory in operation research, the three professors, Charnes, Cooper, and Rode, in 1978, they extended the efficiency definition given by Farrell to cover the multiple inputs and multiple outputs. This technique is a non-parametric technique, linear programming based technique to measure the relative efficiencies of decision-making units, and these units may utilize multiple inputs to produce multiple outputs. So actually, this was a generalization of the Farrell theory. A decision-making unit with efficiency score equal to 1. Here efficiency means relative efficiency. So onward everywhere, when I will say efficiency, it means relative efficiency. So decision making unit with efficiency score equal to 1 is called weakly efficient or technically efficient. And in addition to efficiency score 1, if all input excesses and output shortfalls equal to 0, then it is called fully efficient, or simply it is called efficient. Observe, weakly efficient is also called inefficient decision making unit. This data environment analysis identifies input output slacks and sets input output targets for inefficient DMUs to make them efficient. There are two types of data environment analysis models in BASIC. One is called CCR model, developed by Charnes, Cooper, and Rode in 1978. This was based on the concept of constant return to scale. And second model, which is improvement over CCR model, is called BCC model. This was developed by Banker, Charnes, and Cooper in 1982. This is based on variable returns to scale. I will discuss what is the meaning of return to scale. Here is some literature review in the field of Mgnrega, so I skip it. CCR model, as I said, this is based on constant return to scale. Suppose that we have decision making unit DMU K and its efficiency means relative efficiency EK. Then Charnes, Cooper, and Rode defined to calculate its efficiency EK by the model that efficiency is to be maximized. Efficiency EK is given by summation YRK VRK divided by summation XIK UIK. Here YRK is the rth output of the kth DMU and VRK is the corresponding weight to be determined. YRK is known, VRK is to be determined. Similarly, XIK is the ith input of the kth DMU and UIK is the corresponding weight to be determined. And as I said, relative efficiency is between 0 and 1, 0 exclusive and 1 inclusive. So here is the condition that it must be less than or equal to 1 for all j. And UIK, VRK variables to be determined are greater than or equal to epsilon. Epsilon is a non-Archimedean infinitesimal. So this is a fractional problem. This is to be solved. There are two ways to solve it. The one way is rationalization. So rationalized numerator means impose the condition that the numerator is 1, exactly 1. So condition over the variables u and v. So this additional condition makes our problem as maximize numerator subject to denominator equal to 1. And in the condition we can simplify that numerator minus denominator less than or equal to 0. Okay, this is one way. Other way is impose the condition that numerator is 1. Then it will be reduced to maximize 1 upon numerator, or you can say minimize numerator subject to denominator minus numerator greater than or equal to 0. So these are the two types, which here I have written in the table 1, input output CCR multiplier model. This model is called the fractional model or original CCR model, and after normalization we are getting model 2 and model 3. These are called the multiplier model. So model 2 means maximize efficiency, which is the numerator, subject to denominator equal to 1, and second constant is denominator minus numerator less than or equal to 0. And here in the model 3, minimization of the denominator subject to numerator equal to 1, and next constant is denominator minus numerator greater than or equal to 0. Here are the definitions 1 and 2 corresponding to the models 2 and 3. In model 2, after calculation, it is to determine DMU to be efficient or not. So if the optimal value of EK, which is denoted here EK star, equal to 1, and there exists at least one optimal solution where the U and V are strictly positive, then it is called efficient. Otherwise, CCR inefficient. Means if EK star is smaller than 1, then it is CCR efficient. Or as I said in beginning, EK star is equal to 1, but we are not getting any optimal solution where U and V are positive. Regarding model 3, similar definition is Fk star is the optimal value of Fk, and it is CCR efficient if Fk star is 1 and at least one pair of U and V which is positive. Otherwise, it is inefficient. Okay. Observe that relationship between model 2 and model 3 is that the EK star will be reciprocal of Fk star. And then we are going to have oriented models. Oriented models are obtained by taking dual problem of model 2 and 3. These models 2 and 3 are called multiplier models, and their dual problems are called oriented models. Means envelopment. So input oriented model is obtained by taking the dual problem of model 2, which is here model 4, and model 5 is the dual problem of model 3. So this model 4 is called input oriented envelopment model. Why input oriented? The reason is here. See this one, this right hand side, xik multiplied by theta k. Xik is the input, theta k is objective function. It measures efficiency. So this value theta k lies between 0 and 1. So what is happening? Theta k multiplied by xik. Because of this, it is called input oriented model. And here in model 5, see the right hand side, yrk eta k. Eta k is here the part of objective function, and because of this, it is called output oriented model. Related to model 4, here is the definition 3. By this envelopment model, we can say that a model decision making unit is CCR efficient if theta value is 1 and all slacks are 0. Input output slacks are 0. Input slacks is SIK and output slack is SRK plus star. If this condition is not satisfied, then unit is called CCR inefficient. Similarly, here definition 4 corresponding to model 5, decision making unit is CCR efficient if eta k star is 1 and all slacks are 0, otherwise inefficient. So here otherwise means eta k star is greater than 1 or some slack is positive because it is needed to be 0 to be CCR efficient. After this, we have the next important definition, that is the reference set or peer set. Reference set or peer set for an inefficient DMU is the set of efficient DMUs whose combination makes inefficient DMU as efficient. So with the help of efficient DMUs, an inefficient DMU is made efficient. The set of such efficient DMU is called peer set of inefficient DMU. And its cardinality, means cardinality of peer set, is called peer count. For a numerical example, I will illustrate in detail. Next definition regarding the model 4, suppose that lambda jk star is the optimal value of lambda jk, then the reference set for CCR inefficient DMU based on model 4 is defined by the set Rk is equal to collection of DMU j for which lambda jk star is positive. Lambda jk star is positive. Similarly, with reference to model 5, a reference set is defined by the collection of efficient DMUs for which mu j k star is positive. BCC model, which works based on the variable return to square, is given by introduction of the convexity condition. Here observe in model 4, if you impose the condition over these lambda jk, the convexity condition, see lambda jk are non-negative, impose the condition that summation of lambda jk is 1, it is called the convexity condition. So under this convexity condition, model reduces to a new model, it is called BCC model, Banker, Charnes and Cooper model. Next definition, let theta k star be the optimal value of theta k obtained from here this model 6, which is the BCC model. Then DMU k is said to be BCC efficient if theta k star is 1 and all slacks are 0. Otherwise, decision making unit is called BCC inefficient. Model SBM. The previous two models, means a CCR model, BCC model, these are called radial models. And next is SBM model, slack based model. Actually, the previous model don't consider slacks. Here, this model considers slacks as C from the objective function. This was given by Tom in 2001. And this model is based on non-radial efficiency. So here, model said that minimize 1 minus 1 upon n summation sik divided by xik. You please remember that xik, I means here number of inputs and r means the number of outputs. Denominator is 1 plus 1 upon s. S is the number of outputs. Summation srk plus divided by yrk, r is equal to 1 to s. Sik minus is the input surplus and srk plus is the output slack. Subject to the condition that summation xij lambda jk plus sik minus equal to xik for all I, and summation yrj lambda jk minus SRK plus equal to YRK for all R. And all variables are non-negative. DMUK is said to be SBM efficient if the objective value rho K star is 1 and all flags are 0. Then super SBM model. The three models which we discussed, CCR, BCC and SBM model. After application of these models, we identify efficient and inefficient DMUs. It may happen that there are many decision-making units which are all efficient. Then next problem is how to rank them based on efficiency. So ranking of efficient and inefficient is easy. Based on their efficiency score, it can be ordered first ranking to highest, then lower, so and so forth.
Sir, Yadav sir.
Yes.
Sir, could you make it in a, what do you call it, presentation mode, sir? We could see only small slide in the screen.
You want bigger?
Yes, sir. Because
How to bigger?
no, earlier it is good, but something happened from last two slides. It has become small.
Okay, I am trying.
Yeah, sir. From the last two slides only, it was like that, sir. Earlier it is good.
Now it is okay.
No, sir.
But it is largest one on my screen.
Okay, continue. Go ahead.
Because now we can't make more larger than this. This is largest one. So maybe at your end, some problem.
Okay, sir. Carry on, sir.
Okay. So this was super SBM model. This model is used to rank the efficient decision-making units. This was again proposed by Keynote in 2011. Now return to scale. Return to scale means suppose you are increasing all inputs in some ratio, then we study by how much ratio all outputs are also increased. That is the meaning of return to scale. So here are the two varieties. Constant return to scale, abbreviated as CRS, and variable return to scale, abbreviated as VRS. CRS means suppose that all inputs are increased by a factor of alpha. As a result, if all outputs are also increased by the same alpha, then it is called constant return to scale. Otherwise, it is called variable return to scale. So suppose that inputs are increased by ratio alpha and all outputs by beta. If beta is smaller than alpha, then it is called decreasing return to scale, DRS. If beta is greater than alpha, then it is called increasing return to scale, IRS. Scale efficiency. Efficiency depends on the size of decision-making units. Bigger units tend to produce more output that results in no input cost and hence are more efficient than smaller units. So the scale of economies must be taken into consideration while comparing efficiencies. A decision-making unit is scale efficient if any small change in its size means number of inputs and output, make it inefficient. Scale efficiency is defined as a ratio of CCR efficiency to BCC efficiency. For this talk, I have taken 4 inputs as total number of active workers, all in the logs, approved labor budget, total number of works taken up, total availability of budget, and 5 outputs as average days of employment provided per household, total employment offered, total households, number of completed work, percentage generated so far. All units are in the log. The data has been collected from the official website of Mgnrega for the financial year 2018 to 19. Okay. After taking the data, we examine the two things: consistency of the model and secondly, validity of the data. Consistency of the model is examined by the satisfaction of any two results, n greater than or equal to m into s, or n greater than or equal to 3 times m plus n, where n is the number of decision-making units, m is the number of inputs, and s is the number of outputs. For this study, 29 in our country are the states and union territories. 4 inputs are taken, as I explained earlier, and 5 outputs. So both these results, n greater than or equal to m into s, n greater than or equal to 3 into m plus s, are satisfied. So model is consistent. Means data development analysis models are consistent. They can be applied. Secondly, validity of the data collected. Test name is isotonicity test. In this test, we calculate correlation coefficients between all inputs and all outputs. If these coefficients come out to be positive, then we say that data is valid. If not satisfied, means suppose some correlation coefficient is negative or that is very low, then data is not acceptable. Recollect data or make some arrangement so that correlation coefficient comes out to be positive. Here is the isotonicity test. Observe that in this table, all correlation coefficients are positive. So this test is passed. Means the data collected is justified. We can go ahead. So taking the data, here we have collected CCR efficiency, also BCC efficiency that I will show later on. Here in this table, the result is based on CCR model. Observe here the first column, CCR efficiency, Andhra Pradesh 0.997. In the view of definition of efficiency, this is not efficient, but yes, very near to efficient. Arunachal Pradesh, Assam, they are efficient. Bihar is not efficient. Chhattisgarh, Goa are efficient. Gujarat, not efficient. Haryana, Himachal Pradesh, Jammu and Kashmir, Jharkhand, Kerala are efficient. Karnataka is not efficient. Let us see Andhra Pradesh, the first one. Efficiency score is not 1. So based on the definition, it is not efficient. After calculation of slacks, here S1 comes out to be 59.11. Main thing is positive. This is positive. S3 is also positive. Peer set is 1. Means there is only one state with the help of which Andhra Pradesh can be made to be efficient, and peer weights is 1. Arunachal Pradesh, Assam, they are efficient. Efficient means efficiency score is 1 and all flags are 0. And they come out to be respectively in 2 and 3 states to make them efficient. So here is the explanation from this table. And continuation, observe Madhya Pradesh is efficient, Manipur, Meghalaya, Mizoram, Nagaland, Punjab, Rajasthan, Tamil Nadu, Telangana, Tripura, Uttar Pradesh, Uttarakhand, West Bengal, Andhra Pradesh, they are efficient. Odisha is not efficient. Maharashtra is not efficient. Similarly, we discussed previous slide, efficient and inefficient. Here, peer set and slacks, peer weights, these are important. Peer weight, for example, Maharashtra. Maharashtra can be made efficient with the help of state 5, state 9. State 5 means 5 is here, Chhattisgarh. Chhattisgarh is efficient. Then 9. 9 means Himachal Pradesh. Similarly, 11, 23, so it means 5, 9 means Chhattisgarh and Himachal Pradesh. Then 11 means Jharkhand. 23 means Tamil Nadu. 29 means Andaman Nicobar. So with the help of states 5, 9, 11, 23, 29, with the coefficients, if you write as a linear combination of Maharashtra of with 5, 9, 11, 23 and 29, taking the coefficient to be 0.356, 0.022, 0.181, 0.105, 0.336. So Maharashtra can be made efficient with the help of these 5 states and corresponding weights. Same explanation is for here Odisha. Odisha is also not efficient. So with the help of 5, 11, 23, 26, 28 can be made efficient. And as I said, Andhra Pradesh, with the help of peer set to 1, how it is?
Efficient another. इसमें सिर्फ slack है.
No, it's 0.997, not efficient. Okay, so let us move to other one. So what I said in table. So from the table, clear thing is 23 states and union territory out of the 29 have performed extremely well. Only 6 states have underperformed, namely Andhra Pradesh, efficiency score 0.997, Bihar 0.997, Gujarat 997, Karnataka 0.962, Maharashtra 0.998, and Odisha 0.997. So these states are not efficient, they have underperformed. The state of Andhra Pradesh needs to increase all its output by 0.3% to become fully efficient. This 0.3% is obtained by the target calculation. In addition to the radial increase of 0.3% in all its output, the state of Bihar needs a further increment of 13.47 days in its average employment per household. It also needs a further increase its work completed and percentage generated by 105, 460 and 249.29 percentage. After a radial increment of 0.3%, the state of Gujarat needs to further increase its number of completed work and percentage generated by 74548.132 and 59 percentage respectively. The state of Karnataka needs to increase all of its output by 3.8%, followed by a further increase of 0.11, 1.5, 10529.66 and 344.87 in its average employment per household. Total number of households that worked, number of completed work, and percentage generated respectively. Other than 0.2% of increment in all of its output, the state of Maharashtra needs a further increment of 0.979 days and 46.62% in its average employment per household and the number of percentage generated respectively. The state of Odisha needs to further increase its outputs by 0.3%, followed by increment of 5.377 days and 201.67% in the average employment provided per household and number of percentage generated. So this was the conclusion based on CCR model. Let us have the same data and apply the BCC model. Based on BCC model, the BCC efficiency score, then scale efficiency score, SBM efficiency score are obtained. For Andhra Pradesh, BCC efficiency score is 1. Remember, based on the CCR, efficiency score was 0.997. Based on the BCC model, its efficiency score is 1, so improved. But scale efficiency is again 0.997. So again, Andhra Pradesh is not efficient. But in view of BCC, it is efficient. Based on its size, means the number of inputs and output, it is not efficient. SBM efficiency has come out to be 0.11, that is very small. Similarly, Arunachal Pradesh observed BCC, scale, and SBM all have come out to be well. For Assam, all efficiencies are 1. Bihar, below 1, so it is not efficient. Conclusion based on this is that all states except Bihar, Gujarat, Karnataka, Maharashtra, and Odisha have BCC efficiency score of 1. So here is improvement with respect to Andhra Pradesh. Only the state of Andhra Pradesh is scale inefficient. Andhra Pradesh is BCC efficient, but based on its size, it is not efficient. The state of Goa has topped the ranking with super efficiency score of 1.47, followed by Manipur, Arunachal Pradesh with scores 1.26 and 1.21 respectively. The worst performers are Bihar, Andhra Pradesh, Maharashtra with efficiency, SBM efficiency scores 0.07, 0.11, 0.11 respectively. See, actually, if some decision-making unit is not efficient, but the score is close to 1, then it is considered to be good one. And if it is close to 0, that is not good. Or I can say below 0.5 are not acceptable, above 0.5 can be accepted, and they have good chance of improvement. Here for these 3 states, like Bihar, it is 0.07, Andhra Pradesh 0.11, and similarly for Maharashtra, it is also 0.11. So they are below 0.5. Badly performance. The scheme has performed exceptionally well in states of relatively smaller size. The northeastern states have outperformed the other states of India except the state of Goa. The scheme has failed to perform better in some states with dense population. The states like Bihar, Maharashtra, Karnataka, Gujarat, Odisha, Andhra Pradesh are huge in the terms of area and house of a large population of below poverty line people. These states have proved to be less efficient than the other large in size and high in population states like Madhya Pradesh, Tamil Nadu, Rajasthan, West Bengal, Uttar Pradesh, and Haryana. Overall, the most labor intensive, money consuming, and one of the largest welfare schemes, Mgnrega, is performing excellently and stands up to the purpose it was created for. As in the beginning, in the first slide, I said the purpose of this scheme was to improve the living situation of the disadvantaged people in spite of several deficiencies run by the state government. What I can conclude that this scheme has improved the life of the people concerned. So it can be said that this scheme is performing excellently and stands up to the purpose it was created for. Here are some references based on which the study has been carried out. Thank you. If any question, you can please raise. Mr. Shankar,
Yes, sir. I'm just waiting for audience to.
okay, any question from audience?
Shiv Prasad sir, good afternoon sir. This is Dr. Sridhar.
Sir, you can ask questions, sir.
Shiv Prasad sir,
Yeah,
this is Dr. Sridhar sir from Geetam University, Department of Mathematics.
okay, Dr. Sridhar.
Yes, sir. Hope you are fine, sir.
So no question
think-
from audience?
Sir, I think this content was published in Springer publication, sir.
Okay. No, actually, this lecture is already published somewhere.
Yes, sir.
What you want?
Sir, can we apply estimation theory in that, sir?
Estimation theory, it depends on your data. How is your data?
Sir.
So data means, as you saw in the lecture, main thing is input and output,
Sir.
and number of decision-making units.
Sir.
So based on the two results, as I said, n greater than or equal to m into s, and
Yes,
n greater than or equal to 3 times m plus s.
Yes,
And
sir.
then positiveness of the correlation coefficient. If these things are
Yes.
satisfied by the data, yes, you can apply.
Sir. Thank you, sir. Thank you very much, sir. Sir, Ravishankar, sir.
Sir.
Sir, you can proceed, sir.
Sir, the session is very interesting, sir. So as being a physics person, so I could try to understand that you have taken enough large amount of data related to societal problems, and then trying to make up a model that is related to the data that you have taken and existence of that data. It is quite interesting for me, but sir, one question is that how can we try to so you told that it is in between 0 and 1, And how can we try to implement this, sir?
See
Real
the
time
definition,
Yes, sir.
definition of relative efficiency.
Yes, sir.
After calculating the data,
Yes, sir.
we calculate the efficiency
Yes,
by
sir.
output ratio to input. We consider only single output case. Single input, single output. So
Okay.
for every decision making unit, calculate the ratio of output to input. Okay. After calculating this, pick up the largest ratio. Divide the efficiency by the largest efficiency. Every efficiency will be converted to a value
Yes,
less
sir.
than or equal to 1. This is the main thing. Again, I repeat. Calculate the ratio of output to input. Suppose there are 10 decision making units. All they are having single input and single output. For every unit, calculate the ratio output by input. After calculation of this, pick up the largest ratio. Divide all the ratios by largest ratio. Then resultant can be at most 1. Means this is called the relative efficiency. Relative efficiency. This is the main idea. So what we have done in operations research theory, using the condition that relative efficiency lies between 0 and 1, we impose the condition after modification of the definition. Definition is now linear aggregation of all outputs divided by linear aggregation of all inputs. Okay. This ratio is defined as relative efficiency for the multiple inputs and multiple outputs. Okay. So now we impose the condition that maximize the ratio subject to the condition that ratio is less than or equal to 1. This is the condition. So variables which are the weights you are going to calculate because of the condition that ratio is less than or equal to 1. Now optimal weights will be determined satisfying this condition that ratio linear aggregation of output to linear aggregation of input will be at most 1. So all values will be either 1 or smaller than 1, not more than 1.
Okay, sir. Sir, any questions from the audience, delegates? Sir, I think there are no questions. Sridhar sir, can we wait or? Sir, I think there are no questions, sir. So thank you for your presentation, sir, on this international conference. Over to Sridhar, sir. Sridhar, sir.
Unmute. Unmute.
So thank you, sir. Thank you very much, Professor Shiv Prasad, sir. Your enlightening lecture towards the national conference. And we are very thankful to the organizing committee, especially for Basu sir and his team, for giving us the opportunity to handle the technical session 5 today and tomorrow. And thank you very much, all the participants. No academic event will be successful without the presence of the delegates. So my heartfelt thanks to each and every participant for your active, energetic participation in this academic event. So thank you, one and all. Professor Yadav ji, namaste ji.
Namaste. Thank you.
Thank you, sir.
Should I leave?
Thank you, sir.
Professor Ravi Shankar sir, thank you very much.
Sir. Thank you, sir.
Thank
So
you very much.
Thank you very much, sir.
Thank you.
Can we leave, sir?
Babu sir,
Sir.
just a moment,
Sir,
sir. Just a moment. Babu sir,
మీరు
kindly switch on your video. Sir,
Okay.
switch on video. Unmute your video, sir. Ravi Shankar, sir.
Sir.
Unmute your video, sir, please. If possible, all the participants unmute your video. We will take a photograph of the session. Sir, unmute your video. Babu sir, Ravi Shankar, sir.
Sir, tell me, sir.
Babu sir, are you there, sir?
Yes, yes, sir.
Unmute your video, sir. Nagalakshmi madam. Thank you, sir. Thank you very much. And we'll meet again in evening 6:30 p.m. Sir. Day 1 technical presentation.
Okay, sir. Right.
Thank you, Sri Ram.
Thank you all participations. Next 6 months, 6 o'clock onwards, the technical session will be conducted. Please go on through group, and personally, who are there belongs to their sessions. Kindly cooperate. Kindly walk with their session chairs. Okay. The technical session will be conducted based on the session chairs, and they give the valuable reviews. At right now, few reviews came from Springer. Review reports already came sent to Springer. The Springer reviews along with the corrected presentation reviews. After that, they merge with the past review and present session chairs reviews. Then merge with and rate paper and submit a new version of final version to submit. I will give the end of the month. Okay. Please happy to conduct this conference and make a grand success. Without you, it is not possible. Thank you very much. Thank you, Sridhar sir, for
Thank you, sir. Thank you very much.
for giving a wonderful opportunity as a co-host,
Thank you, sir.
and
Thank you very much.
Sirisha madam also.
Yes, sir. Right now she is in meeting, sir. HOD's meeting.
Yes,
She
yes.
will join with us evening 6:30 p.m. onwards.
Okay, sir. Thank you very
Thank you,
much.
sir.
Thank you very much, all participants.